All right, so for the last section of chapter 9, we're going to kind of go the opposite way of what we did last week. So last week we saw a graph, we made a table of values, or we took a table of values and we made a graph. And then the second thing we looked at is creating patterns using a table of values, all right? Today we're going to go backwards. We're going to use the pattern or the expression that we come up with, okay, for the relationship in the table of values. And that is going to be what we graph and what we make a table of values for, okay? But before we do that, I just wanted to point out one new thing, okay? So we talk about linear relations. That's our whole chapter, okay? And we're looking at table of values, okay, and graphs that when you plot the points, they make a straight line, okay? And so last week, we kind of said, okay, you have to take the table of values, you have to actually graph it to see if it is in fact a linear relation. If it's a straight line, then yes, it is a linear relation. If it's not, it's not, okay? This week, I'm just going to show you a trick, how you can tell something is a linear relation without having to graph it, okay? So both of these statements have to be true for it to be linear. All right, so you need to check off both of these boxes, okay, for it to be linear. Okay, so the x values go up by the same amount each time, and the y values go up by the same amount each time. Oops. So what I mean by that is last week when we had a table of values, oh boy, let's try this again. We had our x and we had our y value, okay? We had our table of values. Now let's say I put this as 2, 3, 4, 5, and my y value is 7, 13, 19, and 25, okay? Now, last week we focused on building the relationship. How do I get from x to y, okay? We wanted the expression the equation that represented that. Okay, it's the relationship between x and y. Okay, that's what we were trying to find, which is known as the pattern. What is the pattern? Okay, that's what we were trying to do. We were going from x to y, and I said you don't want to look at how do I get from x to x. We didn't care about that last week because we were just trying to find the pattern. Well, the trick though is if you want to see if it's linear, all right, is it in fact linear? You actually have to look at, are the x values going up by the same amount? So they're going up by 1 here, they're going up by 1 here, they're going up by 1 here. So they're all going up by the same amount. So the x values are good. So I could come up here and I could check that box. And now are the y's values going up by the same amount? Well, how much are the y's going up by? Well, this one's going up by 6. This one's going up by 6. This was a 5. And this one's going up by 6. Perfect. So the y values are also going up by the same amount, okay? They don't have to be the same number. So x can go up by 1 and y can go up by 6. That's fine, all right? But all the values have to be going up by that same number, okay? So if they're doubling or tripling, whatever it is, but they have to go up by the same amount each time, okay? And that's how you know something is in fact a linear relation, all right? And it's a trick that you can do without having to graph.